Okay, in this video we're going to talk about implicit differentiation, and before we get into partial derivatives we're going to do a review example from Calculus 1, and it's really important you have a good understanding of implicit differentiation from Calculus 1 before moving on to doing implicit differentiation with partial derivatives in Calculus 3. So let's find dy dx. Let's find the rate of change of y with respect to x for x squared times y squared plus x times sine y equals 4. First thing I want to notice is that we've got a product in our first term. We've got a product of x squared times y squared. That's like u times v. And if you recall from Calculus 1, the product rule tells us that the derivative of u times v, so u times v, if we want to do the derivative, that's the derivative of the first times the regular second plus the derivative of the second times the regular first. Okay, so I'm going to go through and do the derivative with respect to x to all terms. In the first term, I've got the derivative with respect to x of x squared times a regular y squared plus the derivative with respect to x of y squared times a regular x squared. And again, that's my product rule. There's the u prime v plus the v prime u. Okay, let's go through and do product rule on our next term. Again, I've got a u times v. So I'm looking at the derivative with respect to x of x times the regular second, which is just sine y, plus the derivative with respect to x of sine y times the regular first term. In other words, there's my u prime v plus my v prime u equals, on the right hand side of this equation, the derivative with respect to x of a constant is just 0. So that one was pretty easy. Let's go through and clean this up. The derivative with respect to x of x squared is just 2x times y squared plus the derivative with respect to x of y squared is 2y times dy dx. I'm using chain rule there and noting that y is a function of x times x squared. The derivative with respect to x of x is just 1 times sine y. Well, let's just write that in a more reasonable way. We'll write it as sine y plus the derivative with respect to x of sine y is cosine y times chain rule dy dx times our regular x, and that equals 0. Let's clean up. So in my first term I have 2xy squared. In the second term I have 2x squared y dy dx plus sine y plus x cosine y dy dx. Okay, at this point we want to collect all the terms with dy dx in it. So I've got 2x squared y dy dx, and I also have another term with dy dx, which is x cosine y dy dx. So I'm going to collect those, and I've got a dy dx times 2x squared y plus an x cosine y. All the terms that don't have dy dx, I'm going to move over to the other side. So that's a 2xy squared and a sine y. I'm going to move those over to the right hand side of my equation. So I've got a negative 2xy squared minus sine y. And lastly, solving for dy dx, we'll divide both sides by this factor 2x squared y plus x cosine y. And goodbye, goodbye. Left hand side looks like a dy dx. Right hand side, final answer is negative 2xy squared minus sine y all over 2x squared y plus x cosine y. Okay, and that would be our final answer. Now again, this is a review from Calc 1, so if this example felt a little bit challenging, please go back to your favorite Calc 1 textbook and do some extra practice. I'm now going to move into an implicit differentiation example. Okay, so now let's find the partial derivative of z with respect to x for x cubed plus y cubed plus z cubed plus 6xyz equals 1. And keep in mind, when we're doing partial derivatives, the variable y is going to act like a constant. So y acts like a constant. Okay, so let's go through this expression. We will take the derivative, the partial derivative with respect to x of all of these terms using our product rule where appropriate. Okay, so let's do it. In the first term, I'm looking at the partial derivative with respect to x of x cubed. Next term, partial derivative with respect to x of y cubed. We're just differentiating each term with respect to x. So for the third term, I've got the partial derivative with respect to x of z cubed. Partial derivative with respect to x of 6xyz. And on the right-hand side, partial derivative with respect to x of the constant 1. Okay, let's clean this up. So the derivative with respect to x of x cubed is 3x squared. The derivative with respect to x of y cubed is 0 because y acts like a constant. And the derivative with respect to x of z cubed is a 3z squared times dz dx. Now the reason why that's a dz dx is because we're looking for the rate of change of z with respect to x. There's some relationship there, and that's what we're trying to find. Z is a function of x. Okay, so we needed to use chain rule right here. You could make a note of that. We use the chain rule. And the reason why the derivative with respect to x of y is 0 is because y is acting like a constant. Okay, now let's move on to a product rule situation here. We're looking at the derivative with respect to x of 6xy. So I'm going to break that up as a product of 6xy, that's like my u, times another factor, z, I'll call that v. And we know that the product rule looks like u prime v plus a v prime u. So let's see how that would work out here. So I would need the derivative with respect to x of u, which is 6xy, times z, plus the derivative with respect to x of z times the regular first 6xy. And on the right hand side we just have 0. Okay, let's keep going and clean up this problem. We have a 3x squared plus 3z squared dz dx plus the partial derivative with respect to x of 6x times y. The partial derivative with respect to x of 6xy, that simply works out to 6y. Remember, x is your variable, y acts like a constant. So the derivative of some constant times x times another constant is just 6y. Okay, and then we had a regular z. No derivative with that factor. Okay, so we're all set there. And now moving on to the derivative, the partial derivative with respect to x of z, that's just going to be dz dx times the regular first factor, which was 6xy. Let's collect all terms which have the dz dx in them. So I've got a dz dx. Factoring that out, we're left with a 3z squared plus 6xy. Any terms without a dz dx in them, I'm going to move over to the right-hand side of the equation. So I'm going to be looking at a negative 3x squared minus 6yz on the right-hand side. Solving for dz dx, we need to divide both sides of the equation by 3z squared plus 6xy. Goodbye, goodbye. Final answer, partial derivative of z with respect to x equals negative 3x squared minus 6yz all over 3z squared plus 6xy.